So the assemble method is the idea is machine learning approach where multiple models, like we have one or three or four models, are combined together so to build a strong model. One model may be wrong sometimes, but if we combine the opinion of many models, the overall predict is more accurate and stable. If you remember, as we last before, we starting with the tree. So we build our tree regression model and classification model. So we need to find the root mean square that have the lowest root mean squares, and we need to develop our accuracy. So we have high accuracy. So the problem with the single model, we have the high variance. The model changed too much with the small changes in the data, and also we have overfitting. Tree may memorize the training data instead of learning general patterns. So we have a three assemble method is bagging, random forest, and bootstrapping. And the idea of assemble method is just to reduce the variance. So reducing variance, and instead of the biggest variance scatter plot, we make them the point is close to each other, and we use the bagging and random forest for reducing variance. And for reducing bias, we use bootstrapping and also increase accuracy. So the assemble help us to increase accuracy compared to a single model. The we have three different types. Each one have some specific different from others. For bagging is also called bootstrap aggregate. Train many models in a parallel on different bootstrapping samples, average, and then average their predictions, regression, or take my majority vote for a classification. For random forest, this is a special case of bagging with decision tree, adding randomness by choosing random features for splitting, make a tree more diverse. And for boosting, where models are trained sequentially, so each new model focus on correcting the error of the previous one. Example, this is add a boost and gradient boosting. So today we'll focus on only the bagging. So instead of we have one single tree, so we will have two, for example, in here, or three or four single tree. And in each tree, the model will choose different variables. For in here start with the budget, and in here start with the trailer view. So and after that, after we predict, the model is predict the average, and for the packaging he will choose this average and calculate the variance. So the packaging start, we have a training data 1, training data 2, 3, 4, depend on number of variables that we have, and we give us the model and the predict 1, predict number 2, 3, 4, and then we combine all this predict, and we have the final model. So and the variance, this is the variance. So the average we'll find from each model, we'll find the average, and then we calculate the variance from the average, and we divide it on the number of trees. So if we have, for example, in here 10 trees, so and the variance is 100, so 100 divided by 10, so equal to 10. So that's how packaging work. So in packaging method, no pruning in packaging, that means the full length there are grown. If you remember, the pruning is when we are cut some part of the tree branches because to reduce the variance, to reduce some noise, so we have the low variance. But in packaging, we allow the model to be overfit, because after that we will use the averaging. We use the average variance, and that one model will use the average variance to calculate the RSS. And in the regression, we take the average of the predicted variables if we have regression data. So numerical data, we will take the average of predict variables. So the model will allow the tree to be full length without cutting anything, and then we'll use the average. We will calculate the average for each prediction. And for classification, we will take the majority vote. The most predicted class will be taken as a final predicted. And for random forest, just the same, it used same as packaging, bootstrap samples, but we add another layer of randomness, and this at each split, so it's like a random subset of a feature, so from the total features. So in here at each split, he will choose random predict. He will choose random independent variables. But in the packaging, for each split, he will choose all the independent variables. But in random, he will choose only one randomly to split the data, and then we get the model. And then the prediction is the same if we have regression or if we have classification data. So let's gonna check in that in the RStudio. We see what's the difference between them. Okay. So for example, we have my data is called df, and I have the same data we used before and same all the class on this training, and this is df where I upload my CSV file called df, and then I have to check for missing value as we said before. So this is just to check if I have missing value. I can cover the missing value by calculating the mean as we said before, and then I have to split my data into train, and I'm going to run that. So after I split my data into test, I have a train data, and I have 80%, and I have test data just to check my test data for unseen, to test our model on the unseen data is 20%. So let's gonna start by we need the package. So we need, for packages, we need to have random forest. We need to have random forest packages to run the packaging and random forest. So for packaging, so we have first, that's gonna fit the model. I'm gonna name it like packaging equal to. So we use the random forest and formula is so formula equal to collection. This is my dependent variables, this is my y, and this is a point for all, and my data equal to train equal to train, and my mtry I'm gonna get equal to 17. So I was gonna run this one. Okay, so I name my as packaging. This is mine. I just naming for my model. I use the random forest as a function in here, not as if this is just for function random forest, and formula equal collection because I have in my dt file I need this one collection to be my independent variables, and all the others is independent variables. Data equal to train, this is the data, I split my data for 18%, and then my try equal to 17, this is for, if you see here the df data, where is my train data? If you see we have in the train data I have 19 variables. So since I have 19 variables, so I have to increase this one to 18 instead of 19. Okay, since I have in the train data I have in here is, you can say 19 variables, so I only choose the collection, this is my y, and all the others gonna be independent variables. So the model, every time he will split the data, he will choose all these 18 variables in my data train. Okay, now let's gonna predict the model with the test data. So test $predict equal to, this is like equal to predict, and the model is called bagging, and on the test data, and check that. If we go for test, so now supposed to find the predicted value with the collection. For this is 39,000, this is 47, and here we check how the more model with the predicted one. Let's go and calculate the MSE. This is most important for bagging. packaging, MSE for packaging equal to, so for MSE for packaging equal to, this is where we calculate the mean, the predicted value, test, $, predicted value minus the true value, it is test, $, and collection, and all that we have to find over the power of 2 and close, and we have to close it from here, calculate the MSE for packaging. So we get the MSE for packaging. So in the previous videos, when we calculate the MSE for full and then for pruned, so we have 93, and for pruned, when we run the normal tree without any packaging, so you can see now we have 35 MSE. We can see the error is going to be reduced because we use the assemble method. So this is from previous model when I run the full model, and then after I run the pruned. If you don't know what I'm talking about, just back to the previous videos, you will see I'm run the full model and the pruned model, and now with packaging I have MSE is lower than, because it's 27, and this is the goal, to find the lowest RMSE. So with the random forest we will do the same, but I'm gonna just take this one with the random forest. Okay, I'm gonna send this one random 4 equal to random forest formula collection data train, but in here I have to use the ntree equal to 5, for example 500, and I run this one, and then the test data predicted. I'm just gonna test data, I'm just gonna name it test random. This is test random, we check that, we go for test, and we can see now we have the predicted, and we have this is random. We can see this is 39, this is 37, this is 38, with compared with the collection is almost the same, not too much different. You can check with your data, and then we have to see this is the MSE, the most important packaging. Now for random, this is random, I'm gonna go for random, MSE for random equal to, so the MSE for random is 37.1, for packaging 37.18, is almost the not too much different. Oh, okay, because I have to change this model, sorry for that. That's why I have to use the random forest, and I have to use in here this random test predicted. Okay, and use test random. Okay, minus this one. So if I check the test now, I'm gonna go for the test. Supposed to be different. So this is 39, 34, this is 35, 39, 35. So you would choose with someone so who give us the minimum RSA. So this is the okay, the MSE we have in here 37.2, and this is 37.4. So with the packaging, it gives us the lower mean square error, and this is how you use the assemble packages to increase the accuracy and reduce variance for decision tree. So thank you for your watching, and please leave me any comments, and thank you if you please me subscribe please, and thank you for your watching. See you in the next video.